Hello 108 students, Mr. McCue here. We're back at section 10.2 and we're going to keep working with our exponential functions. And this talking class notes section we're going to focus on page 2. And first we're going to start off with a brief summary of what we just found out on page 1. And so if you have the graph of an exponential function, it's the form f of x, of course that's the y, equals the base, which is a, raised to the x. We concluded a couple of things from the previous page 1 of our notes. Will always contain point 0, comma 1. Think of that as the turning point, or the elbow point's my nickname for it. Next, we could consider that when the base a was greater than 1, the graph rises left to right. You can think of that as growth. That's an exponential growth graph. When a is between 0 and 1, which means it's a fraction, the growth falls. Think of that as decay. Oops. And we kind of mentioned that we were not going to consider the base being equal to 1, because 1 raised to any exponent always equals 1 and would produce a horizontal line graph from the second quadrant to the first. Okay, another conclusion, number 3, we have the graph will approach the x-axis but never touch it. Therefore the x-axis, which is y equals 0 down here, is called the asymptote. I did not mention that in the last page there, but that is a definition you should get comfortable with. This is where the graph will never cross over. It's called the asymptote. Okay, finally the domains for these, as you look at the function, the domain is going on the x, the horizontal. You're going from negative infinity. It'll go over, it'll never cross the x-axis, but it'll keep going out and out. Finally, on the x-axis, it'll go higher and higher and higher. So you're going from negative infinity to infinity. Okay. And the range, which is going on the y-axis, you are going to start at 0 but never touch it. Again, we've explained that. And as the graph is going up on the y, the vertical, it'll approach infinity, positive infinity. Okay, so you can make those conclusions there. Next thing we're going to work on is I have example 3 written here, where you get maybe for some of your homework problems. They're going to ask you to graph ones that look a little tad more complicated. What you want to keep in mind here, if you look at this problem, you've got f of x equals the base 3 raised to the exponent 2x minus 4. The key to doing these problems is to find the elbow or turning point. And that is where you are going to have the base 3 raised to the 0 power, because that's going to equal 1. Now, what we need to do is take the expression up in the exponent, which happens to be 2x minus 4, and set that equal to 0 and solve for x. So we'll add 4 to both sides, divide by 2, and we've got that x equals 2. So that's a critical point you always want to find. That's why I've got the star here. So this is called the elbow point. So when x equals 2, it produces 3 raised to the 0, which is 1, and 2 comma 1 is your elbow or turning point. Okay, now for these graphs, when you're doing My Math Lab, you just need to get a general feel. I recommend you go on the x-axis, go 1 down, 1 above where you found the turning point. If you let x equal 1, you get 2 times 1 is 2, minus 4 is negative 2, which is 3, raised to the negative 2, which is 1 over 3 squared, which produces the 1/9. And so now you're about right here, approximately. And if you go 1 above it at 3, you get 2 times 3 is 6, minus 4 is 2, 3 squared is 9. Watch that nitty-gritty work right there, the math, make sure you get it right. 3 comma 9, look how quickly the exponential graph rises. Here's 3, here's 9, and within one unit of x, you make a huge, big, steep crease. Again, so you look at this, I would classify this as a growth graph again, just because the base is 3, so that's holding true when you look at it. And again, as you go down with negative values of x, you'll never cross the x-axis where y equals 0. Okay, so there's our graph for those. You want to take advantage of finding the turning point or elbow point. What value of x makes the exponent expression equal to 0? Once you've got that, just find a value of x below and above it, plug into your expanded xy table, and you will be good to go. Okay, so I've summarized here page 2. Keep in mind, find that turning point, and you will be able to graph these. And my math lab, by the way, you will just simply be picking from multiple choice options here. There is no tool in a palette that actually will produce graphs for you. Okay, you're just going to select them. So in your homework, make sure you work them out by hand, pick a couple points so you feel comfortable with this. Okay, that's all for now here. Mr. McCue going to sign out. When I talk to you again, we'll be moving on to page 3. Okay, I'll see you then.